Hello there. In this video we'll be solving exercise on probability. The first question: how many 4-digit numbers can be formed from the digits 1, 3, 5, 7, 8 and 9, where a digit is used at most once, and first case if the number must be even? Okay, obviously 4-digit numbers, it has 4 places: unit place, tens place, hundreds place and thousand place. Now if the number is even, obviously the unit digit should be even number. So from the given digits, which one is the even one? It's just only 8, so that we have one chance here. Now when you get back to the thousand place, we can take any of the number but other than 8. Already the 8 is already taken, because the digit will be used at most once. So we can have 5 chances here. There are totally 6 digits, but we are going to construct 4-digit numbers. So we have 5 chances here. So multiply with, in the hundred place, we can have now 4 chances, because 2 numbers already taken. One number is for unit place, and the other number is for thousand place. So we can have 4 chances here. And next it's going to be 3 chance. So we'll multiply all them. So the answer is going to be 60. So we can have 60 different possible 4-digit numbers which are even, can be formed. The second one, B, still a 4-digit number, but it says the number must be less than 1000. So in the thousand place we cannot write a number other than 1. If you take 3, it will be 3000 something. If it is 5, 5000 something, it will be getting greater and greater than 3000. So it doesn't work. The number must be less than 3000. So the only number that can be written this time in the thousand place will be just 1. In the hundred place, now we can take any of the numbers, for any of the 5 digits. So we have 5 chance, next 4 chance, and next 3 chance, because digits cannot be repeated. So again it will be 60 different possible 4-digit numbers can be formed which are less than 3000. When you go to the next question, again here it says 2 men and a woman are lined up to have their picture taken. If they are arranged at random, find the number of ways that the woman will be on the left and the woman will be at the middle. Obviously this one, if the woman is to the left side, if the women represented by M, and the 2 men M1 and M2 can be in this way, or the other one still the women to the left and M2 M1. We have 2 way of arrangement. We can do it in this way, or we can say there are 3 people, so 3 minus 1 factorial. Why 3 minus 1? Because the place of the woman is already fixed. We cannot reshuffle her. We have to fix her the woman place. So the main place will be can be changed, but the woman place will be the same. So that is going to be 2 factorial. 2 factorial means it's 2. The same manner we go to B. If the woman is at the middle, so we can do M1 W M2, or the other possibility M2 W M1. The 2 men can change their place, but the woman will be fixed at the middle. Therefore, the same manner, 3 minus 1 factorial also, it works this time, which is 2 factorial, because the woman place is fixed. When you go to the next question, it says, find the number of permutations that can be made out of the letters of the word mathematics. In how many of these permutations do the word starts with C? First of all, try to count the number of digits what we have here. We have around 11 digits. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are there. Of course, there will be repetition. But the first one, it says, do the words start with C? So one number, one letter is already fixed. The first letter will be C, so we cannot touch that part. So the other number, we have now 10 letters. So the number of permutation will be 10 factorial over, we have to count those letters which are repeated. There will be 2 M's and 2 S and also 2 T's. So we need to write as the denominator 2 factorial times 2 factorial times 2 factorial. It will be somehow bigger number, but that's the way how to do. Once again, let me repeat. We have already 11 letters here in the word mathematics, but one of the letter that is C is it has a fixed place, because the word that we are going to write will be it will start with letter C, so no need to touch that. So the remaining 10 letters we have. So how to, in how many ways we can have this permutation? 10 factorial over the letter repetition. M is repeated, A is repeated, and T is repeated. Each of them are repeated twice. So 2 factorial over 2 factorial times 2 factorial. That's going to be the formula. And when you go to B, do all the vowels occur together. What are the vowels this time? The vowels are A, E, A, and I. A, E, and AI. We can consider them like one letter. From the 11, 1, 2, 3, 4. When you subtract 4, how many letters remains? It's going to be 7 letters. What are they? M, T, H, again M, T, C, and S. 1, 2, 3, 4, 5, 6, 7 letters. Okay, so this will be counted as 1 because all the vowels will be together. Means all the vowels, keep them together and count them as 1. Therefore, together we will have 8 letters. So the total number of permutation will be 8 factorial over, we need to again still here consider the repeated letters. That's M and T. So the A already forget it because the A is already together with the vowel, so we can skip this one. They are together like one letter. But the M's are 2M are there and 2 T's are there. So we have to say 2 factorial times 2 factorial. So you get some kind of bigger number, but that's the way how to do. You know, 8 factorial means 8 times, 7 times, 6 times, 6 times, 5 times, 4 times, until multiply times 1. You need to continue. You need to go down. So that's the way how to answer for B. When you go to C, do the words begin with H and end with S. Again here, this time in case of C, 2 places are already fixed, the first and the last. So 2 letters are already fixed. So from 11 minus 2 will be, you know, it's 9. So 9 factorial. So the total number of permutation will be 9 factorial over. Now we need to count those repeated letters. We said already before 2M, 2A, and 2T. So it's going to be 2 factorial times 2 factorial times 2 factorial. That's the way how to do. Okay, let's proceed. In a library, there are 3 mathematics, 4 geography, and 3 economics books. If each of them will be put on a shelf and each type of a book are identical, here is the key point. What does he say? If each of the book will be put on the shelf and each type of the book are identical. So in how many ways can be these books be arranged? Of course, 3 plus 4 plus 3 will be 10 books are there. So the total number of permutation will be 10 factorial over 3 factorial times 3 factorial times 4 factorial, because the books are identical. They are identical. The 3 maths are the same, the 3 geography are the same, and the 3 economics are. What if they are not the same? What are we going to do if they are not? What if they are not the same? If they are not identical, first of all, the 3 maths. The 3 math book will be arranged by 3 factorial, and the 4 geo also will be arranged in 4 factorial ways, and the 3 economics also will be arranged in 3 factorial books. And there are 3 different subjects are there, so this is going to be 3 factorial again. So totally the total number of arrangement will be 3 factorial times 3 factorial times 4 factorial times 3 factorial. Don't forget, the first 3 factorial is because there are 3 subjects, but each of the subjects, they are not the same. For example, 3 maths means they are not identical. Here I'm trying to do if not identical. In case of identical, this is a way how to do. Just the total number of books are 10, so 10 factorial over 3 books of math and 4 books of geography and 3 books of economics are the same, so that 3 factorial times 3 factorial times 4 factorial will be the denominator part so that you can finish it. But if they are not identical, the 3 math book also they do have different arrangement. So what to do? 3 factorial, and the geo also 3, and the economics also 3. Again, at the same time, there are 3 subjects. They need a rearrangement again, so that 3 factorial it will be. So totally 3 factorial multiplied with 3 factorial times 3 factorial times 3 factorial. Okay. The next question, what does it say? Verify that n permutation n minus 1 is equal to n permutation n. This n is down. So you know n permutation r, the formula is n factorial over n minus r factorial. This is the formula. So let's apply that one here. So when you do that, for the first part, n factorial over n minus 1, the whole factorial. It must be equal to, we are asked to verify or prove that n factorial over n minus n factorial. This time the negative will be distributed, this negative, and what will happen? Negative will be positive. So n factorial over n minus n plus 1 factorial, which is equal to n factorial over 0 factorial. But here n minus n will be cancelled out, this one, and what remain? Plus 1. 1 factorial means, you know, it's 1. So what I will have now, n factorial upper part left, the lower part, the right part will be 0 factorial also, it's the same as 1. So what left? N factorial. This was what we were looking for. It says, are they equal, or verify that the two are equal? Yes. Finally, through process, we end up at some point, which is n factorial is equal to n factorial. They are equal. Okay. One last question. What does it say? Find the factorial of each of the following numbers. A, we need to find 6 factorial. This is the same as 6 times, 5 times, 4 times, 3 times, 2 times 1. That is our definition of factorial. When you multiply, you will get 720. Times 1 actually doesn't have any effect. B, 8 factorial. Again, 8 times, 7 times, 6 times, go on until you multiply by 1, and then you will get a result here. And the last one, 12 factorial, it will be somehow a big number, because 12 times, 11 times, 10 times, look, multiply until times 1. Finally, there will be a result. That's the way how to do the exercise, and that's going to be the end of the video.